Test. Good morning, everybody. Oh, wow, we got a lot of people this time around. Hey, folks, how's it going?
Good.
Good, how are you?
I'm quite well. Got a good group this morning. I think we'll wait, 5 or so minutes to start. People always trickle in late to these kinds of things. In the meantime, y'all just tell me a little bit about how you heard about this particular workshop.
I got it from my son-in-law. He's a data scientist.
Sweet. Took another class, or maybe he follows my mailing list.
Yeah, he took a class from you last week. I'm not sure which one he did, but I meant to take it last Monday, but I didn't set it up.
These things happen.
Yeah.
This was sent to me through my PI. I'm not sure who he got it from.
Cool. Haha, the word spreads. I love it. Eric, Surya, Haro.
Hi,
Hi.
Tyler. Yeah, I'm in Courtney Miller's lab at Scripps, and got an email
sweet.
from
The
one of my
CPV.
friends. Yeah, thanks for doing this. I'm excited. I've never learned anything programming or anything major computer related, so I'm excited.
Yeah, sweet. It's a whole cute little world.
This is Eric. I got it through the Scripps mail list.
Okay, cool. Scripps, the little Scripps connection.
Yeah, Haru and I are also from Scripps.
Oh, right on. Do any of you Scripps people happen to know Sabaul Hassan? She's my Scripps connection.
Oh,
Yeah, I'm in
Yeah.
the bioinformatics user group.
Oh, nice. Okay, we'll wait 2 more minutes here. Does anyone already have experience using a programming language in this group?
I do, but a long time ago. I'm 62, so I learned programming, Fortran, BASIC, C in the early days.
The classics.
Yeah, I did some early Windows programming before Windows was really a thing.
Okay.
And I'm a geologist, so I've done programming within the packages that I use. So I have some experience doing programming, but any heavy duty stuff's been decades.
Okay, cool. And what language do you use right now, mostly for that work?
It's a proprietary programming language to the software.
Oh, okay, cool.
But they're pretty much all the same.
Yeah, once you know 2 or 3, you know them all.
Well, some people probably do, not me.
And then there's something like Haskell or Prolog, which really throws in a wrench in your whole idea of what a programming language is. But that's neither here nor there. Anybody else speak a programming language like R or JavaScript or C?
Yeah, this is Eric. I have a lot of experience with C, C++, primarily R now. I teach the Scripps R class and advanced R class. Do a lot of package development.
Okay, cool. A lot of Python, I think, is going to feel familiar for you then. This will be a little bit review. For those folks who haven't spoken a programming language before, If you're not, we're gonna, start from the absolute basics here and kind of work our way up. It might feel quick. This is, a short workshop, but I'm trying to give a relatively large tour. But we're also going to have a good chance to practice, especially reading code, and maybe we'll get some chance to actually feel good enough to write a few significant programs if we go fast. But we'll see. Might be mostly just writing a couple extra lines of code. Is everyone also able to get the materials that were linked on the page, the GitHub materials, as well as download Visual Studio Code?
Yeah, I downloaded.
I'm now downloading.
Okay, cool.
Yeah, I got the GitHub. It's a little I mean, I'm not familiar with this sort of thing, so it's a little I'm a little off base with it. And I've got the Visual Studio Code editor, and it's one of the more complex editors I've ever seen. So
Fully featured.
I mean, back in the
Okay.
day, I used to just write it in a text editor and just run it through a compiler and see what happened.
Oh yeah, we're not even going to compile anything. It's just going to run. Boom. Pretty exciting.
That's yeah.
Yeah, what are you using? VI, Emacs?
VI, yes, yeah, I remember that. That's stripping away some cobwebs.
Okay. If you had trouble downloading the materials, what I suggest is going to this website, which I'll send in chat again. It's on the website, but it's easier just to pop it in here. Boom. And then if you're not familiar with GitHub, the easiest thing to do is just click download zip. So clone or download and then download zip. And then save this, open it up. And you'll end up, see, I've already done this. So replace that. Yeah, sure. Where's my downloads? Can unzip it real quick, and then this folder, you can open that folder in Visual Studio Code. So if you open Visual Studio Code, go File, Open, and then navigate to that folder. I'm going to use a different version because this is where I actually have the code saved on my machine, but you just open up the whole folder, and boom, you should have something that looks like this. When you click on this file, these two files, you should be able to see all the code here. Why did this thing move so far down my screen? There we go. Okay. So let's see, it's 10:07. Anybody who shows up after this is late, and the natural consequences for being late, right? You miss a little content. So basically, the first thing I want to do, I had the objectives for today up on the whiteboard. Let's go back there. Basically, before we dive into, I just showed you how to download the materials, but before we dive into the syntax of Python and the, most critical building blocks of Python, I kind of want to talk a little bit about what we're doing today, what the goals are for today, and why Python. It's a really popular programming language. I'm sure you've heard of it before this workshop. So, this is a question for the group. What's the deal with Python? Why is it important or interesting?
That's a good question. I mean, me being exposed to multiple programming languages over my lifetime, and now it's starting to seem to focus down into a single programming language.
Yeah, so you're saying you have encountered many, but now you spend your time really just working with the one.
Well, no, I'm not working with Python at all. That's why I'm here. Just mostly curiosity, and there's some job possibilities that ask questions. Are you familiar with Python for running simulations and other software?
Okay, sure. What else? Who else has been exposed to Python? Have any idea what it's good for, what it's bad at?
I know it's used a lot in the bioinformatics world, and so I do a lot of analyses with R in that, and just wanted to learn it to get more tools to use for analysis.
Yeah, and one of the big differences between like Python and R, as programming languages, they're pretty similar, but the ecosystems that are built around them, which libraries exist, are very different. And so I've also heard that Python is becoming quite popular in bioinformatics and kind of in the data science realm and kind of the academic realm in general. I would say like MATLAB and R used to be much more popular than Python, and now Python is kind of making a play in the academic world. Do you think that's accurate, you academics?
Yeah, I see that a lot. There's machine learning tools that I've noticed are becoming more online with Python and accessible than in R, or at least it takes our time to catch up to.
Yeah, absolutely. And a lot of like, Google releases Python packages for TensorFlow, but maybe doesn't release the R packages very fast. Keras comes to mind, a deep learning workshop or a deep learning framework.
Yeah, it's TensorFlow actually that it's sparked a lot of my interest.
TensorFlow, it's a great library. It's pretty fun stuff. You done any deep learning specifically?
Mainly with a lot with random forest. I've written a package for it,
Okay.
and just use a lot of different tools and a lot of unsupervised learning. But yeah, trying to move to TensorFlow now.
Cool. Well, that's exciting. Yeah, Python is great for that. There's lots of good libraries. My running joke is that Python is the second best language for everything. It may not be the perfect domain-specific language for any one particular task, but it's a very flexible language. It's got widespread application from like we're talking about machine learning, data science, deep learning, bioinformatics, that type of stuff, but also is widely used in web development, building web servers, managing web servers, and even building some kinds of native applications and microcontroller units like the Raspberry Pi now. You can execute Python there, and there's a lot of interesting packages for doing, electronics, microcontroller unit type work. So Python's extremely flexible. That's one of the pros. Um, Cons, I would say, like many interpreted languages, which Python is an example of, it can be a little slower. So if you're doing stuff like the interesting thing about TensorFlow, the library we were just talking about, is when you need it to run in high performance mode, the Python code actually generates C code, and then the C code gets compiled, and then the compiled C code executes. So it's this really weird three-step process that's all hidden from you as the user, but it makes your Python code look like it's running really fast when what's actually happening under the hood is we're generating code, compiling that code, and then running compiled C code when we want something to be fast. So your general Python scripts, if you built them from scratch and then you built the same program in C from scratch, the C program usually runs like 5 to 10 times faster. So there is some significant slowdown, but it's also a lot easier to learn than C. As you'll see, a lot of stuff in Python is pretty straightforward. The syntax is easy. It handles a lot of different data types kind of relatively elegantly for you without you having to think too much about it. So those are some of the pros, in my opinion, of Python. Anything else burning on people's minds? Yeah, Samantha. It just highlighted your box because some kind of sound came out of your microphone. That's why I called on you.
Oh, sorry, I just moved.
That's fine. I'm the Panopticon. I'm watching you. If you turned your cameras on, I would be able to see your face and have even a better idea when you had a question.
I have a question.
Good, hit me.
So I tried to find I've got the tutorial here in front of me, but how do I link the two together to bring it up in the Studio Code editor? I went to File Open,
Oh yeah.
but I don't see how to get from that point from the editor over to the
Okay. Yeah, you go File Open, and then wherever you saved it. Whoops, I grabbed the wrong thing here. I want to move.
wondering, I thought it would have gone to some nice spot, but
Yeah, Downloads folder probably. What are you on a Windows system?
yes, sir.
When you clicked here and you did download, you download this file.
Yes,
Where was it saved?
that's a good question. I did it late at night and I was half awake.
Well, that's the most important thing. That's what you need to know in order to
Yes.
get there.
Would it be under data?
I don't know. On Windows, I don't know if you have something similar, but in Macland, we have just our regular file thing, and you could search for the name of that thing is going to be intro to programming.
Oh,
So
okay.
you might be able to find it that way by typing into a search bar or something like that.
I'll have that running while you continue.
Sweet. Okay, and so then what we were paused on is basically any questions about why Python or what's interesting about Python before I tell you basically what I'm going to tell you about Python. And then I'll start telling you what I'm about to tell you I'm going to tell you about Python. Okay, that's the sound of crickets. So, if you have questions, please just always interrupt me. Questions are better than not questions. So basically, here's the goal for today's lesson. I'm going to introduce you to the syntax of Python and, kind of what I consider to be the alphabet of Python and the basic grammar. We're going to learn to read and write basic sentences. It might feel slow, it might feel fast. It just depends on how comfortable people are with some of these topics. I find some people really take to this stuff super easily and they're like, oh my God, it makes sense. I love it. And other people are like, whoa, this is really hard. So, you might be anywhere in between there. But the goal is to, do what you would have done in kindergarten as far as reading and writing. We need to get the basic fundamentals. We need to know what the alphabet is. We need to know what it means to have sentences. We need to know what the key building blocks. And these building blocks are pretty much the building blocks of every programming language. Most of this is not specific to Python, except for the specific syntax, the way the text gets written. But you'll see variables and data types, operators, control flow, lists, loops, dictionaries, and functions are things that exist in every programming language. And we're going to see how to use those tools and build those things specifically in Python, but there are analogous ways to do that in any other programming language. So for the folks of you who have seen R or MATLAB code before, some of these terms already probably sound familiar, like you've used variables and operators. But this is the basic goal here. Get us to core familiarity with the basic concepts of programming languages. And then from there, you can take this knowledge and kind of hopefully springboard yourself into the machine learning tools that you want to use, start figuring out how to import libraries and do other more complex things, reading data from files or connecting to a SQL database, that kind of thing. But this is the sort of crawl before you can walk workshop, okay? So any questions about that kind of the goals, what we're doing?
Good to go.
Groovy. Then this is the time when it's best for everyone to have their environment all set up. So questions about how to get to this point where I am in the code, basically. And I can do this from scratch, actually. I'll open Visual Studio Code. We go File, Open. You find the folder wherever you downloaded it for this particular workshop, which again is at this website. You clicked clone or download, you downloaded the zip file, you unzip the zip file. Find that look. Go ahead.
I'm still having issues finding what I did with it.
Oh no, I might ask you to share your screen. Would you be comfortable doing that? And I could help you debug.
Well, the problem is I have a big computer in my laptop and I didn't put it on my laptop and I don't have, well, I guess I could fire up Zoom on this other one here, huh?
Yeah, you could. Or so you're using your laptop to do the Zoom and you have all your other stuff on the big computer?
Yeah, on my main computer here.
Got it. Yeah, you could put Zoom on the main computer if that's where you're going to do your programming. You could also do your programming on the laptop.
Yeah, but I've got lots of real estate.
Fair enough. Anybody else having trouble getting to this point? And this, by the way, this code that's on the screen is in the code examples folder. This is number 1, data types and variables. So you can get this code on the screen. But if you can get this code on the screen, then you're in good shape. Jim, do you want to get Zoom running on your other machine?
Yeah, it says it's launching.
Okay. Everyone who is here, if you were able to install the Python extension, you should have a little play button in the top right of your corner. If you're on this screen, just try clicking that and look at this terminal output for a second. It should say something like this. Okay, Nick, we'll admit you. Nick.
That's me. It took my son's name over. All right. I am here. Can you see me?
I can't see you yet.
It'd be Nick.
Yeah, no, I see that you're in the room. I don't
Okay.
see your face or your screen share.
Yeah, because the large computer doesn't have the
Camera.
camera or the audio. So I'm talking to you through my laptop.
Okay, cool. On your big computer, will you do a share screen? I'll stop sharing so that you will be allowed to.
Where do I do that?
In the Zoom window, near the
Right.
bottom.
I think I'm screen one. I have a dual screen setup.
That's the best. Okay, sweet.
Oh, are you good?
I am good. I can see your screen now. Okay, so open up your file, like your folder window.
There you go.
I can't see that. I see the screen with 2 web browsers. The one that just launched Zoom is in the forefront. So maybe you shared the other screen. There. Okay, yes.
Okay, let me move visual over here as well.
And that was search results. Okay, so in the window with the search results, type in the little search bar where it says Nick right now.
Yep.
Search for intro -to -programming.
Intro -to Let me try from the very root of things.
Yeah, good idea.
Not there, and then my other.
No dice.
Nothing.
Okay, go back to GitHub and try doing the zip download again. We'll be able to see where it installs, where it downloads from your browser, and we'll just be able to go straight there.
What was the pathway again?
GitHub.com/ it's in chat, actually. Do you have the
There we go.
chat?
Yeah, all right.
Okay, search in Find a Repository, search for, actually just go to /tebs-lab, TEBS, github.com/teb, in the URL bar.
In the URL bar? Okay.
Yep, github.com/ I meant. TEBS hyphen, oh, there you go, it's coming up. Click on that, Tebs Lab, Intro to Programming. It's okay, the purple link is the one you want. Tebs Lab, Intro to Programming, down partway through this.
Was I there?
Yeah, you were there twice. You can find it from this link too.
Please bear with me, folks. All right, there we go, Tebs. All right, where am I looking?
See the purple link on your screen about a quarter way down?
Right here?
Tebs Lab, one up. Intro to Programming, that's the one you want. Clone or download, download zip. Okay, now click where it came up in your bottom little window here. Yes.
No.
Click the little up arrow. Is it doing something on a different window?
Yeah, it brought up the WinRAR for some
Okay,
reason.
pull that into view. Extract to.
Extract to.
directly above where your mouse is.
Extract to. Okay.
And now tell it where you want it to save the files.
All right. I'll put it right there.
Okay.
Okay.
Okay, so now you know where that location was, downloads.
Yes, sir.
So open that up in Visual Studio Code. Okay, but you need to use the, oh no, this is right, just click open right now.
Open.
Yep.
It's asking me to pick code examples or exercises or one of these others.
You should be able to open the whole folder. Click, yeah, okay, highlight that and then click open.
And it goes there.
That's kind of annoying.
It's not behaving like your Mac.
Pull your Visual Studio Code window into screen for me. Close
I
that.
also have a PC. If you open just that top folder, that's what I did, and then you can pull up the first example.
Click open folder instead of open file. Do that same flow you just did. Click open folder. There you go. Hi-oh. Okay, now you can click on Intro to Programming Master, and it'll open up all the files below it. Boom. And now you've got the code examples. We're in code examples number 1.
You can teach an old dog new tricks. There we go.
I sure can. I'm going to take over sharing of your screen. It's my screen now.
Okay.
Okay, great. So what are we looking at here? This is some very basic Python code. The first and most important thing we're talking about are variables and data types. These are two terms. You might have heard both of these terms before. Does someone want to try and define them for me?
X equals 1 and X equals or Y equals text code, right?
Yes, these two lines of code are setting x equal to 1, a numeric data type, okay? And x is the name of our variable. Y is the name of the second variable, and these strings, little single quotes, make this a different type of data called a string. So the difference between these is one is a number, like you can do math with numbers, and specifically it's an integer. It's a whole number, not a fractional, no decimals, nothing like that. It's 1, it's 2, it's 3, it's an integer. And this is text for like displaying and for reading, okay? So we have two variables and we have two data types. Can we define those terms more, generally? What is a variable? Eric, Hario, Samantha?
It's an object that contains a value.
I like that. Yeah, it's a thing that contains a value. I'm going to avoid using the term object because there's a specific programming term called an object, which sounds super vague, but actually has kind of annoyingly specific meaning, especially in languages like JavaScript.
Right.
But yes, so it's a thing and it contains a value. And we give this thing a name, and the name that we've chosen is X and Y in this case. Okay? And what about data types? This is a term that I've said now 3 or 4 times. I've vaguely explained. Why do we need different data types?
You mean like real or integer or character?
Sure. Yes, all 3 of those are different data types.
Yep.
And their purpose is like, I hope it's clear that we can do math on this number here. We can't do math on this number. This is a number like an address would be a number, and it would be mixed with strings, 1875 Texas Street, that's my mom's address, please don't dox her or something like that, We can mix our text, 1, 2, 3, G, H, F, right? And this is still a legitimate use of a variable, okay? We can store this meaningless string into it. Okay, so we create variables and we create data and we put data in variables so that we can reuse or process that data later. And basically all of programming is about getting data, transforming it a little bit, and then storing it. That's pretty much all of data processing, whether you're doing a lot of it in a very complex way to do machine learning models and then use those models later to create predictions about whatever your target interest is. How is this gene going to be expressed in my plant? I think that'd be a really cool example use case of one of these machine learning models, or whether you're doing web requests, you're doing a web server, data comes to you, you process it, oh, that data says this is Tyler and he's a new user, he should get stored in my database. So fundamentally, all we're ever doing is getting data in, changing that data, and putting data out. And different kinds of data have different data types because the data means different things and it can be processed in different ways. Numbers, you can do math. Strings, you just have text. There's a few other important types of data we're going to see down below. But do you have questions about, what a variable is, why we use them, what data is? This is the most probably important piece of programming, the use of variables to store data.
I'm good.
We're good. Okay. Here you can see I'm printing. Print is a function. We'll talk more about functions later, but they're just blocks of code that do useful things. Many functions are built into Python, and we call them with this syntax here. You use an opening parenthesis and a closing parenthesis, and any data in between those parentheses is sent to the function. So we're saying, send this string quotes to the function print. The result of that is down here in our terminal where it prints quotes. And then these two things, we're printing the type of X, we're printing the type of Y, result in Python telling you what I've just been telling you for 2 minutes. One of these is an integer, int, and one of these is a string, str. And this is just the way Python communicates to programmers about what the type is. It uses this class keyword that's meaningful, but I want to punt on the meaning of the class keyword for some later time. It's a little more complex. Okay, there's 3 types of numbers that are built into Python: integer numbers, floating point or decimal numbers, and complex numbers. I've literally never seen a case when anyone needed to use these. So if you're in a field where you work with complex numbers, maybe you will. But this is like if you think back to high school, I don't know if it's algebra or calculus, but like the square root of -2, right, or whatever it is. Square root of -1 is I, and that's what J is. Okay, I never use these, but Python has support for them. Kind of crazy. If we print those 3 things out, we see they're different types: integers, floating, and complex. I think this is an interesting fact that if you've never programmed before, it wouldn't be clear why you would have different types for integers and floating points. Why might that be? Aren't numbers just numbers?
Well, integers are non-decimal. So floats they'll have decimal components to them, as far as I understand integers and float numbers.
Yes, that's true. And they're stored differently under the hood on the machine. We have, like, our processor has its own way of reckoning with numbers, and the data storage formats for integer values, number 2, and floating point values, 0.1, are surprisingly different. But we can work with these numbers together. We can say, like, example 3 is equal to 2 plus 0.2, 0.2, and Python will make the math work. Even though these are different types, integers and floats, we can still combine them like this using addition or subtraction. We'll see more examples in the next slide of addition and subtraction. and operators, other operators for combining data. Okay.
Just as a sidebar, I remember back in the day in Fortran, you had to classify those at the start of the program, whether they're integers or floats. And it looks like now you can they just go on the fly.
Okay, yes, actually, and that's a great point for anyone who speaks a programming language like C. So this is two examples of two kinds of programming languages. One is called a statically typed programming language. And in statically typed programming languages, you always have to say, when you're creating a variable, you would have to mark this variable, say, this is an integer X. And then you could create the variable and you could store integer data into that variable. And you would have to say, this is a string Y. And you could then store string typed data into that variable named Y. Python is what's called a dynamically typed programming language, which means as the code executes line by line, the type of the variable is determined automatically by the programming language. And it also means I can change the type of a variable. So X is currently an integer, and I could reassign X to be a string. And this would be perfectly legal in Python, and it would not work in a statically typed programming language, because in a statically typed programming language, every variable has to be told what its data type is. But we don't have to do that in Python. We can just mix and match and change as much as we want. Okay. This is another important data type, Booleans. We ask lots of true and false questions in programming land, and we'll see in if 2 slides from now or 2 notebooks from now, 2 files, 2 Python files from now, we'll see that we use comparison operators to answer true-false questions all the time, and then do certain things. If this condition is true, store the user in the database. If this user already exists, update their user record. If this user doesn't already exist in the database, create that user record, stuff like this. So we use true-false all the time, and in Python, capital T true and capital F false are literal true false values, just like the number 1 means the number 1. Whoops, let's control Z. I didn't mean to delete false here. So these are reserved values, and you can see like all the syntax highlighting is very useful. Print is a known function, so it gets a special color. Type is another built-in function, so it gets its own color. True and false are blue. That means it's a built-in value. None down here gets another built-in value. Strings change color too, you'll see. So the code editor we're using gives us a lot of nudges about what stuff is an important reserved keyword. And the point here being, I can't make a variable named false, right? This is a line of code that won't work because false is not allowed to be a variable name. Does that make sense?
Yes.
Tyler, a question from our land.
Awesome.
Are those the only 2 representations of true and false?
Yes.
Can it be shortened to T or F?
No.
Okay, thanks.
Once I've done this, I can use my variable T and F as true and false. But I wouldn't recommend it. That's not really safe. If you want to ask a question, is something the true value true? You should always write out capital T RUE.
Okay, thanks.
Sweet. Okay, and then none is a special type. Most programming languages have this special type, so it's good to grapple with. None means there is no value, a lack of a value, an absence of a value. A lot of other programming languages call this null, so you might have heard null before. And again, it's capital N O-N-E, and that just means there is no data here, but it's kind of like an explicit there is no data here. We expect data to be here later, and it's not there. Or say someone filled out a form, and it's like first name, middle name, last name, and you don't have a middle name, or you just have a first name. Then middle name and last name are going to be none. You don't have one. There is no data that fits there, that kind of a thing. So this is a special reserved value for when values are missing. Okay. And that's basically what I want to say about, the foundational data types, numbers, strings, Booleans, the vast majority of your primitive data types are going to be one of those forms. And then when you get more and more complex data, you're going to have combinations of those forms. So maybe you store DNA data as long strings representing, nucleotides. Or maybe you've heard of FASTQ files. Those are text data that are also representations of genetic data, but they're even more complex and they have a specific formatting that, the text has to be in this exact way. And then you have a program that reads the text that looks that way and turns it into meaningful information about DNA. But all your complex data is built up from these simple data types, okay? So the next thing we want to do is be able to combine and compare data in a programming language. So here's some examples. We're doing basic math here. And at this point, I want to show you how to kind of step through code in Visual Studio Code. I think this is both a really useful way to debug programs, even when you're a seasoned expert developer, but it's also a good way to get into the mindset of thinking like a computer, which is a huge hurdle that a lot of people have difficulty getting across, and really understanding just how sequential and literal and pedantic computers behave. So what I clicked over here in the left, and if you hover, it'll say something like breakpoint. Okay. If you do the same thing, you click to the left of these lines of code, and then you click on this little bug/run thing, you'll get a little window that says this, run and debug. If you click run and debug, and then select Python file, then you'll be dropped into this situation and you'll see this new command thing, this new window pops up and you can move it. I guess I can't move it all the way down. That's slightly annoying, but I'll just put it right here. And you'll see this turned orange, indicating, hey, you're in the middle of executing code. And my terminal popped up some input. It said, hey, run this file, compare and combine. And now right here is the line of code that I'm on for terminal output. So when I run the print command up here in this code, it'll print down here. Okay, so the most important thing over here is in this locals frame. And right now we're paused prior to the execution of this function on line 2 that says 2 = 1 + 1, okay? If I click this button, this stands for step over a line of code. And you can see if I hover over, it says that. These two are step into and step out of. Those are for calling functions, which we haven't done anything with yet, but you'll see how they work too. But so when we step over this line of code, that line of code is going to get executed. Okay, so I clicked it, and now I'm paused prior to running the line of code on line 3. And you can see over here, it said, hey, I made a new local variable. Okay, so that's what locals is for. There are global variables that are available everywhere in the code. And then there are local variables, which are only really relevant. In this case, it's local to this file. And in functions, functions have their own scope, and those variables will be local to a function. Okay, but so I've created a variable here, variable 2, and it's got the value of 2. Can everybody do this? Are you able to do this on your screen?
Yes.
Yeah.
Sweet. Where's my manage participants? I want. Okay. So when I click this step over again, what's going to happen? Can we describe what happens on this line of code?
It'll perform the mathematics and assign it to the variable 6.
That's exactly right. I'm going to go 2 times 3. That'll be the number 6. I'll get a new variable named 6, and it'll appear over here in my locals. So now I can do the same thing. I can combine variables using operators, just like I combine numbers using operators. Variables just hold data, so I can do any operator I could do on raw numbers. I could do on variables that are holding raw numbers. And if I execute this line of code, it'll compute 6 divided by 2. And I should say the name of these You know, the programming language is not interpreting the names of these. The fact that I have written 3 as the name for my variable has nothing to do with the fact that it holds this data, 3.0. Okay, that was something interesting. Why do you suppose 6 and 2 don't have a decimal value, but 3 has a decimal value? I think that's really interesting. What happened there?
Good question.
Samantha, you want to make a guess?
Did it convert the integers to be a float now?
That's exactly what happened, yeah. Okay, so Python, we learned its default behavior when you're doing division is to turn, even if you're doing division with 2 integers, it's to return the value as a floating point number. I think that's actually a really sensible decision, but why? And maybe I'll add a line of code. We'll help
I'll say
Luke.
one thing on my visual, my editor, it did not turn 3 into a real value.
We might be using different versions of Python. So in Python 2, do you see over here?
Mine
Oh,
said
hey, actually, I'll have to type my version of Python here. I'm using, you can see at the bottom, it says I'm using Python 3.7.6.
2.7.6, 32-bit.
Okay, yeah, so this is a change from Python 2 to Python 3, which by the way was a huge change that almost broke the entire Python community. We thought it was going to fall apart. It was really hilarious. But Python 3 made a bunch of really significant changes, and this is one example of them. The division operator between 2 integers used to return an integer, which means in Python 2, 1 divided by 2 isn't 0.5, it's 0. It's 0.5 rounded down to the nearest integer. Okay, whereas now if I'm stepping through this code, oh, I added Q after I stopped the or after I started the debugger. So I'm just gonna run this to completion, run this again. Step, 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 step. Okay. Q executed, Q got 0.5. Whereas with integer division, it would have been 1 divided by 2, which would have evaluated to 0.5, and then the decimal part is thrown away with raw integer division. So this is the kind of thing that, you know, Python 3 has our back, Python 2 doesn't really have our back, and this is the kind of thing that programmers have to think about when we're talking about different types of data. If you're using 2 integers, many programming languages will say the answer to line 16 here, Q 1 divided by 2, the correct answer for a lot of programs and a lot of programming languages is that that means 0. And that's not wrong. It's the correct application of integer division. Whereas with floating point division, 1.0 divided by 2.0, that should be 0.5 for many programming languages. Okay, so this is a kind of frustration that programmers have to deal with that regular people don't ever have to deal with. You know, no one in your life has asked you, hey, what's 1 divided by 2? And you had to think to yourself, integer or floating point? You know, you just said that's a half.
so.
Yeah, 2 questions.
Sorry, is there a reason for the placement of the locals? Because it doesn't go in the exact order that we ran the code in.
Oh, yeah. So I don't know how Python decides to order these. Looking at it right here, it looks alphabetical to me. Q,
Yeah.
R, S, T, U, V, X, Y, Z. But it's not really meaningful from the program's perspective. All of these live somewhere in memory, and the program just keeps track of it. The Python interpreter keeps track of it for us.
Okay.
Does that make sense?
Yes.
Okay, cool. And then Jim, I think you had a question too.
Yeah, I was just wondering, it's kind of a off topic. When I thought I downloaded Python through your website, so I'm a little surprised that I didn't get.
Oh no. The
version.
only thing that you downloaded through my website are these files, the files here in the code examples and the exercises.
Okay.
Python, what version of Python you have almost certainly came pre-installed with Windows. So Windows and Mac and Linux all have a version of Python installed by default.
So is the latest version a purchase, or is this freeware, shareware kind of stuff?
Python's all free. Yeah, you can get any version of Python for free with the standard implementation.
So what's the latest edition, rendition of the Python?
I think Python
that we should
3.7
about?
is latest.
3.8 is what I
3.8 has been
downloaded.
released. 3.8 has been released. Oh my gosh, I should update. How exciting. Oh, good, I have something to look forward to. Python 8. Well, 3.8, it's still Python 3. Yeah, and I mean, really, you should definitely get off of any of the version 2s. Python 2 has been end of life. There's no more support for it, including no more security releases for it. But all of the versions of Python 3 have backwards security releases. You should really get up to at least 3.7. Now that 8's released and it's 2 versions in, I'll update to 3.8 as well. So that's my recommendation, but definitely get off of Python 2 if you want to do any serious programming in it.
We're good to go for what we're doing today.
Yes, for today, it should be fine.
Okay.
There will be a few oddities here and there.
Like that.
Yeah. Okay, so these are like mathematical operations. You know, I think they all make sense. We've all done multiplication, addition, subtraction, blah, 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 blah. We can do it with variables. We can do it with numbers. There's also this, the difference between single equals and double equals, okay? So if I step over this line of code on line 21, it'll print comparing for me. And if I step over again, it'll print true. Okay, so this line of code is asking the question, is the data in the variable named 2 equal to the data in the variable named x? And if we go back to our little debug window, we can just see that x contains 2 and 2 contains 2. We can also hover over these and Visual Studio Code will tell us the values of them. That's pretty useful. But so 2 equals 2 and it said true, 2 equals 2, okay? So this is comparison operator, the equality comparison operator, which is different from single equals, which is the assignment operator. Q gets this value, whereas this produces a value. It says, what's the answer to this question of equality? Okay, and all 3 of these are true. If I step over them, 6 is 6 and y is 6. 3 is 3 and z is 3, okay? And then we just print a blank line here. Now, on this next line of code, I want to ask you all the question. Oh wait, I've got something for this. Oh no, I don't have a poll for this. Okay, well anyway, I'm gonna ask you the question. Is this true or false? So take 10 seconds, decide whether you think that 1 double equals 1 is gonna be true or false. And then we'll discuss.
That's false.
Why?
Well, 1 is numerical and 1 is a string. Double quotes is a string, unless 1 is, well, I don't think 1 can be considered a variable, so.
No,
yeah,
you're exactly right. So this data here, this is the number 1. This data here, this is the text, this is the string 1, and they're not going to be equal. So when I step over this line, it prints this thing here as a literal string, so it just prints that whole piece of text to my screen, and that's just to remind you which thing it's saying is true or false about. That's a helpful clue to us, the programmers. And then it resolves this operator into the value false, because if data doesn't have the same type, it's not the same in Python. And the only exception to that is 3.0, this is equal to 3. This will return true, even though this is a float and this is a int. They're both number types, and you can always compare number types, even if they're not the same type in Python. But if you compare a number to a string, it will always be false in Python. Okay. So you can do other, standard comparisons. Less than. This is greater than or equal to. This is greater than. We can step over those and prove that they print what we think they're going to print. Oh, they don't actually print. They just execute, so that's not very useful.
Okay, so on that line there, the pound true is
This is a comment.
that's comment. Okay, got it.
Yes, I should probably explain that. Everything on a line of code following a hashtag or pound sign in Python is ignored by the interpreter, which means it's only for developers' consumption. So this is just a message to us, and the program ignores it. And similarly, up until here, this is code that gets executed by the interpreter. So it says, is Albert less than Bill? And the result of this will be true. But then over here, following this hashtag, it's just ignored. It just says true. And that true is just for the developer to read. It's just from me. Okay, this is a slight oddity of programming languages. In most programming languages, and this has to do with the way the data is stored and encoded under the hood. I don't want to get into it too much, but you might encounter this if you're sorting things. Capital letters all come before lowercase letters. So capital B is less than lowercase a, which is a little weird if we think of sorting things alphabetically. That's not how we would do it, but that's how Python does it. So, say la vie, we deal with it. But we can use these operators to compare all kinds of data. We can also use operators down below. Let's step over. We can also use operators on strings, okay? So here, we're gonna replace the value that's currently in x. So x currently contains the number 2, and we're gonna replace it with hello plus world, which isn't addition anymore. Now this is, because these are two strings, now this is something called concatenation. So we'll place the two strings next to each other, and if we step over, we'll see x now has the string value, hello space world, period. Okay. When you're working with strings, multiplication becomes duplication, which is kind of interesting. But so a times 4 means 4 a's, a. And I could do, x times 4, and it would be hello world, period, hello world, period, hello world, period, hello world, period. Okay. I think I jumped out there, but I wasn't saying anything, so you didn't miss anything. The last, go ahead.
If you were to do x equals 4 times that, would you have to put a parent around that? Or would it know to do hello plus, what's the
order of operations. So you're saying if I do times 4 right here?
So do the first on the left and then times 4?
Let's find out. I don't actually know what the order of ops will be for that. So I'm gonna finish this. I'm gonna move my breakpoint from the top all the way to the line that we're interested in. Okay, I'm gonna run and debug, Python file. Now it'll run the code, it'll stop on this line, and we'll step over and find out. I suspect it's gonna be hello plus world, 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 world. That's what I think is gonna happen, but I'm not sure. Ha, I love it when I'm right. Hello, world, 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 world. So multiplication, well, duplication, has taken precedence over plus. And if we wanted hello, world, hello, world, hello, world, we could do, as you said, we could do this.
So the orders, the mathematical operators would function on that when you're doing things of that nature, like concatenation, etc.
Yes, there's still, yeah. An order of operations is followed by the programming language. Please excuse my dear Aunt Sally. And for stuff that's not math, it's always a defined order of operations, but it's defined by the programming language, and sometimes you have to look it up to make sure it's doing what you think it's doing. Okay, so I altered this to do the parentheses, and now I think we should get hello world 4 times. Let's see. Hello world, hello world, hello world, hello world. Beautiful. Okay, the last operations I want to show you. Oh, and this is going to break. I'm going to go x equals 1 here so that this actually works. And I'll undo my change here. I'm going to have to make some updates on the website to make this work for next time. But this is good, okay? Now we're down here on this line. We're going to skip over, skip over. We're going to set x equal to 1. These last 4 operators are combining doing some math with assigning a value. Okay, so here we're saying x plus equals 1. That means add 1 to x and store the result back into x. Okay, so if I step over this line of code, x is 1 right now, and after this line of code executes, it's going to be 2. Okay, we can see it updated to 2. This means subtract 1 from x and store the result back into x. So it'll go back to 1. This is boring. It means multiply x by 1 and store the result back into x, but since we've got 1 and 1, we're just going to stick with 1. And this means divide x by 1 and store the result back into x, which this one will always also put x back to whatever it is. But for completion's sake, I want to show you these operators. They're used really, really quite commonly in programming. Short meeting, Eric. Okay.
Yeah, we moved it, sorry.
No worries. So I want to open up at this moment for questions about what we've done so far. We've done data types, we've done operators, and then you've been in your chair with me for about an hour. So I'm going to recommend that you stand up, do a little bit of stretching, use the bathroom, get a cup of coffee, take a 5-minute break. But first, questions about what we've done so far.
Yeah, quick question about logicals.
Mhm.
Can they be converted to numerics? Can they be converted to 0 and 1?
Oh, I don't know if there's some, because you want to do, then that happens a lot in languages like C, right? Where you do the logical operator and the data is actually stored as a 0 or 1. I
Yeah,
don't,
so in R, one things we use, again, I'm sorry, it just helps my
no, it's really good.
comprehension. Logicals can be converted to 0s and 1s, and so it's easy to do things like percentages or sums to
Oh,
count things that meet a condition or don't meet that condition. So you can take the mean of a set of logicals and get a proportion. And I just want to know if that capability was in Python.
I think you can do that. Let's test it out really quick. I think you can do it like this. Let's say 1 equals int true. I think this is the proper way. This casts
Okay.
your value into an integer.
Okay. Excellent.
Let's test to make sure it works the way I think it does, though.
Yeah.
Okay, boom, we'll step over. Oh, good Lord, that was silly. Print 1. Hey, look at that, 1.
Excellent.
Yeah, so that'll work. And we should probably just check false does what we think it does too.
So all of these flags that
Excellent.
come up while you're using your editor, is that the editor version where you're bringing up all of the clues, or is that the Python part of it?
Oh, that's the editor. You're saying like as I'm typing, it
Right.
gives me hints
That.
about what to use. That's Visual Studio Code.
Is there a way to turn that on and off?
Almost certainly. I don't know how to do it offhand. I like it on, so I've never tried to turn it off.
Okay, because I'm sorry to go on a side course here, but I'm not seeing that sort of help file come up while I'm hovering over some of the objects here, whereas when you were doing that, it was dynamic.
Oh, you can only, hovering over like the data will only work when you're in the middle of a debug session. So like right now, the code is in the process of being executed and all, X has a value right now at this moment in time. Whereas say if I click stop here and now I'm not in a debug session, right now, there is no X, there is no variables, there are no data. This code is just waiting to be run.
Sure,
And
sure.
makes sense.
Yeah, those I'm getting that information. It's like for the operators like print, and when you brought up the
Oh, when I do this.
yeah, see that I'm not seeing that. I don't know about the other folks on the line.
I'm curious. Anybody else, yes, getting this like little helpful information when you hover over the function, or no, not getting it?
No, I don't get it.
Interesting. So far as I know, I haven't done anything
Oh wait, I'm sorry,
intentionally.
I was on the wrong thing. Yes, I do get it.
Oh, Samantha does get it. Well, I don't know. I'll have to look through like the help documentation to figure out how to turn this on for you, Jim, because I didn't do anything to do it and it just happens.
Okay.
It might
Thanks.
be the version of Python as well.
It could be the version of Python and it could be the version of Visual Studio. Those are two good places to look.
Sure.
But any more questions about, these two topics that we've done in Python, and then we're going to do 5-minute break. Okay, in that case, I'll get my favorite 5-minute timer. It's not actually my favorite, it's just easy to do. Okay, we're on break. Okay, time's up. Is everyone back? Can I just get an affirmative? I'm back.
Yes.
Here.
Here.
Eric's here, Jim's here,
Here.
Sarah's here. Okay, sweet. Dope. In that case, we're going to talk about control flow in Python. As we've seen with the debugger, code executes from the top down. Control flow is a mechanism to change that, or at least cause some code to execute only under certain conditions, which is very, very useful. Any meaningful amount of code uses this kind of logical branching. Like the example I gave earlier is if a user already exists, update that user's account. If not, create a new account for that user. If this customer has their credit card saved, tell them they have their credit card saved. If not, ask them to upload their credit card information so we can charge them. This kind of stuff. And it happens in all of programming. You just need to be able to decide based on the data, based on the current situation, based on the input from the program to do something or not do something. And so if statements and loops are the two main forms of control flow, along with functions, which we'll see in just a second, that help us control what code gets executed under what condition, okay? So we strangely, for no good reason up here, are defining a variable called x. That's going to be another update I make to the materials. Okay, and then here we just see if true, print this code. If false, this never executes. And so the syntax here for Python is if, you can see that it's purple. If is a special reserved keyword. And then following the if statement, we have anything that evaluates to a value will work. Ultimately, it will be reduced to a true or false value, but I can do if one, and Python has to decide if one is true or false, which it will decide one is true, by the way. And there's a whole list of truthy, falsy. I could Google that for you. Python truthy, falsy values. If you have a piece of data that's not true or false, Python tells you which one it is by this notion of truthiness or falsiness. Wow, these docs are really old. Let's go 3.8. I wonder if they even maintain it. Nope. Okay, but you can read this free code camp article about truthiness and falsiness. It's kind of neither here nor there when we're talking about just how to do if statements. So if, and then followed by some data, and then the colon. And the colon indicates basically, in the case that this is true, do the code following the colon. And then I have 4 spaces here. Okay, Python is the only programming language actually that I know that does things this way. There may be other ones that I'm not familiar with, but in Python, these 4 spaces, and it could be a tab or it could be 4 spaces. It's better to do 4 spaces. That's kind of the established best practice. But this white space is not ignored. It has syntactical meaning in Python. So every line of code that is indented 4 spaces underneath of this if statement belongs to this if statement. So that is, these 2 lines of code will happen because this is true. And I could do another line here, print this also never.
So do you get a syntax error if you don't space it in like that? Or a
Yes.
programming error, you'll get an error. Yeah.
Yes, and if you do something like this, where I have 4 spaces and then 5 spaces, this will throw you an error as well. And if I did 4 spaces here and a tab here, that will also throw you an error. So you have to be really careful and precise. And by default, I think my text editor replaces, if I'm hitting the tab character, it just puts in 4 spaces. That's good. That's what you want for Python. 4 spaces is the established best practice for every level of indentation. You just always do 4 spaces. And that's just by convention. This is perfectly legal to do just 1 space each. And if I run this code, it'll work just fine. So I can put a breakpoint right here and I can do my little debug, run this Python file, and this executes, and I can step over this and it also executes. You'll see neither of these 2 things executed, and now I'm all the way down on this line of code because if false evaluates to false, right? So these 2 things don't happen. But this is not
Sorry,
recommended.
question.
Mhm.
So in the syntax or the spacing you had before, we had just 1 space. Those 2 print statements executed because they're part of the if statement?
Correct.
Or, okay. Not, so I'm confused about what if the 4 spaces is required or not required to indicate that a set of statements are part of like an if statement, for instance.
It's not required, but it's a convention that the Python community has decided we should all follow. We all ought to follow.
Then how do you denote that the statements that follow are no longer part of the if statement? So if you
Oh,
wanted to have print this executes as part of the if statement and this also executes as not part of the if statement.
good question. You just go back to the previous level of indentation. So wherever this if statement was indented, which in our case is 0 levels of indentation, right?
Okay.
0, then this is now back to regular land. And these will both still execute, but this one will execute because the if statement, and this one will execute regardless.
Okay, so indentation determines the grouping of lines of code.
That's exactly correct.
Okay.
And for those of you who speak another programming language, most other programming languages I know of do this with curly braces. So in
Yes.
like JavaScript, yes, from Eric means R probably does this. I should speak R, but I
Yes.
don't. Yeah, C does this. So
Yes. Yeah. Yeah. Okay.
this is one of the only things I actually like a little better about other programming languages than Python. I kind of like the explicitness of the curly brace, but
Structured.
c'est la vie.
So if you had a line break between the 2 prints, but you had the indentation, that'll operate under the if statement, or is that a break?
Nope,
Is
these
that
are,
an error?
no, this is allowed and they're both still part of the if statement.
Okay.
Sweet. Okay, and then, as you'd imagine, we don't usually just do if statements with if true. We have some data and we want to do comparisons on that data to determine whether or not we should execute the if statements. So here's an example. If this arbitrary number is bigger than 10, do this top line. And here's something new that we haven't seen before if you're one of the folks here who's totally new to programming languages, maybe never before, is this else clause, okay? And with if statements, you can combine them with an else statement to say, if something is true, do the thing under the if statement. Otherwise, if that didn't happen, do the thing under the else statement. So this is a way to say only one of these 2 things should ever happen, and we can pick which one should happen using else. Okay. We can take it one step further with elif. Okay, so actually let's just step through this. We've got an arbitrary number, it's 42. And so we ended up printing, I don't know, I think I must have accidentally clicked step over twice, but you can see it printed the number is larger than 10. So we know that this line of code executed and this one did not. You know what? I think I know what's going on actually. I'm going to stop this and rerun it when we get right here with a breakpoint right here. I added some code and I think that caused its positioning to be off. Okay. So we'll go here. Now we're here, okay. And we have an arbitrary number, it's 42. So with elif, it still means only one of these 4 blocks of code should execute. And it'll first say, is the number less than 10? If so, this happens and nothing else happens. Then elif means, if the number wasn't less than 10, but it is less than 20, execute this. The number is between 10 and 20. Otherwise, if it wasn't less than 10 and it wasn't less than 20 and it is less than 30, do this. And finally, otherwise, if none of those executed, do the number is less than 30. And if we step, it determined none of these were the case, so I've got to go ahead and print that the number is larger than 30 because our number is 42. So our 3 programming newbies, how do you feel about if, else, and elif?
That makes sense.
Sweet.
It's surprising how common I've done basic, Fortran, and C, and the syntactical structure is pretty much the same.
Yeah. I mean, we figured we got this one right early on, and all the other programming languages were like, yeah, we need that.
I surmise that you have do loops and things like that as well.
Yeah, we have 2 kinds of loops in Python, while and for, and we'll see those in the next. Actually, we'll just see for loops in the next one, but I can show you a while loop anyway. Okay, and then this last section is showing you can do complex comparisons with data using not, and or. Okay, so not takes a comparison and it reverses the truthiness of it. Okay, so our number is 42, which is in fact greater than 10. So this here, 42 greater than 10, resolves to true, but because we have not in front of it, it'll become false, and this will not print. For the other programmers who've already seen other programming languages, this is much like the exclamation point operator in many languages. And Python still has the exclamation point operator, but it's suggested when you're doing, when you're writing if statements, use not because it's easy to read. That's what the Python community kind of prefers, but you'll see it mixed and matched. You'll see this like if bang arbitrary number. This means the same thing, but for everyone who doesn't speak a programming language already, I hope that's obviously not as clear. Whereas this is kind of clear to read. If, well, not entirely, but if not arbitrary number greater than 10, do this. And requires that both of the things on either side of the and, both of the operators are true. So this will only happen if the number is both greater than 10 and less than 50, meaning if it's in between 10 and 50. Whereas this down here is the opposite. Or means only one of the 2 things needs to be true, and then all evaluate to true. So in this case, if the number is less than 10 or it's larger than 30, this will execute. Okay, and so we can see, remember our arbitrary number is 42. So this won't happen because arbitrary number is greater than 10 and will not that. Okay, so we skipped over it, see? Didn't print. Now we're going to do, is the number greater than 10 and less than 50? And this one's true, so we'll print. Okay, and you can see we jumped down into that line of code because these are both true. And then we're going to be asking, is 42 less than 10? False. And is 42 greater than 30? That's true. So we'll also do this one, even though the first part of it evaluated to false. Since the second part evaluated to true, we print. Blammo. Okay. Questions about if statements? How they work, what they do, what they're good for? Sweet. Okay, then we've got 3 more little mini topics before I ask you to do some fun code, well, I hope fun, challenging code reading exercises. Okay, the main things we have to do next are talk about collections of data. So we've talked about variables, and we can store single values into variables, and we can control the flow of the code based on the value in those variables. But what about, we're often not just dealing with single values. We want to perform the same operations over and over again to a collection of data that, represents the same things. I've got a collection of test scores, or I've got a collection of, RNA sequences, or I've got a collection of customer records, and I want to process them all in some similar way to determine something about those customers or those nucleotides or whatever it is. Okay, so we use lists in Python generally to do that. And you make a list using these 2 square brackets. This is an empty list, a list with nothing in it. Okay, so it's the same thing we've been doing. We'll add a little breakpoint. We'll execute this code as we step through it. And we can see over here in local, I get an empty list. It's got nothing in it. This is going to create a list with 6 numbers, the numbers 1 through 6. And this one's going to create a list with 6 strings, A, B, C, D, E, and F. Blam, blam. And you'll see I can also open these lists in my debugger. And it tells me what's in each position. So in the 0th position, I have the number 1. In the 1th position, I have the number 2. In the 2th position, I have the number 3. This is a little bit of programmer stuff. If you haven't seen this before, you'd never know. And we'll talk about it right here on this line of code too. But lists are indexed starting at 0 in most programming languages. I think the only one I know that doesn't do that is MATLAB. But so we say this 1 here is in the 0th position of the array, not the 1st position, even though it's technically accurate to say it's in the 1st position. We access it using the number 0 down here. So when we say L1 and I do bracket notation, I'm asking for a value from that array. So I'm saying L1 sub 0, give me the thing at the 0th position and print it out to the screen. And so that will print 1 because that's what's in the 0th position of this first list, list 1. Oh, Eric's telling me R also indexes starting at 1. So R and MATLAB. How about it? And this is the kind of thing you can fight holy wars over. Should it be indexed starting at 1? Should it be indexed starting at 0? Who knows? There's not necessarily a right answer, but people like to think there is. Okay, so my newbie programmers, how do you feel about this idea of collections of data in a list?
It seems to make sense.
Wait, yeah. We want lists, we want to do things. They have an order, so I should show you, right? This, I put the data in order, 1, 2, 3, 4, 5, 6. Here, the data is out of order, and that's the way it's stored. I told it to put the data out of order, and it stores it for me in the order that I specified, which is good. We wouldn't want the thing to secretly reorder our data behind our backs. That'd be annoying. Okay, then pop quiz. This here is going to print a value to our screen. What value will it print? Take, 5 seconds and decide, make a guess, write it down, hold yourself accountable. And I'll make sure you can see L2 is on the screen. We're going to print L2 sub 3. Haria, what do you think? What is this going to print?
E?
Sorry, say that again.
Is it D?
Let's find out. Step over.
Hmm.
Boom, it is D. Well done. Okay, right, because that's the thing in position 0, 1, 2, 3.
It starts with 0.
Right. Okay, what about this? Position in -1. This is a cute Python idiosyncrasy. Any guesses? Remember, it's referencing list 3 here.
4.
3?
4 is a reasonable guess. 3 is a reasonable guess. Let's step over and find out. 3 is what it does. Okay, so there's only one 0. There's not -0. This is 0, and -1 goes around the horn
Ah,
to 3. So I've only seen this in Python. Some other programming languages also probably maybe have it.
why would you do that?
Usually people do this just as a shorthand for, I want to know what the last thing is in the list. Because the other way to get the last thing in the list is like, I want to know the length of
Yeah.
the list I'm getting for -1, and that's kind of annoying to write. Whoops, and I have to do this whole thing like L3 sub the length of that list -1, and then I do the bracket notation right there. Now these two things do the same thing. They both tell me what's the last item in the list.
That's a shortcut.
Yeah. Right, and for all of us, this is how Python gets the length of a list. You call this built-in len function, short for length, on the list, and that'll tell you how many things there are in that list. So this is, there's 1, 2, 3, 4, 5, 6 things in the list. It's 0 indexed, so this is the 5th position. 0, 1, 2, 3, 4, 5. So 6 minus 1 is 5, which gets me this 3. And this is just a much easier way to say that same thing. But it's good to kind of see this. Sometimes you have to be explicit. Okay, so when we have lists, the most common thing we want to do is loop over those lists. And in Python, we do that with a for loop. So when we say for I, short for item in this case, and the for loop syntax requires us to use this in keyword. So for I creates a variable named I. In L1 means this variable I will be assigned for each iteration through the for loop. It'll be assigned the values in L1 iteratively. It'll get 1 and then 2 and then 3 and then 4. So we can kind of step through that and see it happening. And then I print 1, and then it increments to the next one, which is 2. And then it prints 2. And you can also see I is getting a value here updated. It gets updated to 3, then I print 3. Then it gets updated to 4, and then I print 4. So on and so on and so on. Until I'm done with the list, I gets 6, which was the last value in the list, and then we move on. Notice here that I is still available. That's kind of interesting. We can still use the variable I right here. It exists now, and it still just is 6. So that can be a gotcha if you didn't mean to, if you didn't know that this I variable persists, and you thought it meant something different. It can still be there, but not a huge deal. Okay, same thing for list 2. We'll print A, B, C, D, E, F, G. Nothing crazy, or sorry, just F, not G. And then for L3, which is the numbers, but in a wacky order, it prints them right in that wacky order, the order that I specified, okay? So this is looping relatively straightforward. Any questions about how the for loop operates? The indentation white space rules are the same as they are for if statements, by the way. Everything indented 4 spaces under this for loop belongs to that for loop, and you can do, lots of lines of code in a for loop. Cool. Okay, then I'm going to show you one more very useful function in Python, this enumerate function. When we pretty much only use enumerate in the context of for loops, but if we want the index value, that's the name of, if I open up this list here, this 0 means index 0 holds the value 1, index 1 holds the value 2. If I want the index as well as the value, I can call enumerate on my list, and I'll get both of those values at the same time in Python. So now if I step, we'll see at index 0 in list 2, the value is A. And so I'll print 0 and A. And the next time I'll get index 1 and value B. Let's soak this up, you can see value at the same time here. And so on and so forth. And sometimes this can be useful, for example, if I want to look one ahead or one behind me at the same time. I could say if L2 at index plus 1 is equal to value, this would tell me, is the item one ahead of me in the list the same as me as this current value? And if I wanted to do something, I could print like, I'm the same as my neighbor. If I could spell neighbor, at least, that's what I would do.
Tyler, quick question.
Yeah.
It's a bit esoteric, but does modifying index change the behavior of the for loop within the loop?
Ooh, yeah, good question. No, it will not. It will just change the value of that variable.
Okay. Thanks.
Mm-hmm. Okay, so I'll step over, we'll print the rest of these. And then here is a different way to get items in. This is pretty common to do. So this dot notation is going to be new for our fresh programmers here. This list data type is a complex data type, and it has, as we've seen, values that exist inside of the list. I can create a list with data in it. I can also say, using this dot notation, call functions that modify this list. And in our case, we're appending values to a list. So what did I call that list? New list, and you can see it right here. It's got a length of 0, it's empty. When I say new list dot append hello, and I execute that line of code, you can see hello has been added to the new list at position 0. And if I step again, good is going to be added at position 1. And now the length of the list is 2. And then, again, people gets added at position 2. And now the length is 3. There's 3 things in the list. So I can iteratively add things to this as well. Shplam, and then, I can print the whole list out and its length and doodle doodle do. So questions about lists and for loops?
Just another sort of esoteric performance question.
Mhm.
Is it standard sort of Python dogma to allocate size and then fill rather than do iterative appends?
No, in Python, typically you don't have to know the size beforehand and you don't really set it. There is a way, and I think if you're looking for very high performance, you want to do something like list 100. And then it'll create space for 100 things under the hood. But it's pretty good at dynamically growing the array quickly. So most of the time you don't need to do this.
Okay, thanks.
Mhm.
So does it care if that's a one-dimensional array or two-dimensional array or a three-dimensional array?
It's a one-dimensional array by default, and if you want lists in lists, you can go like, well, we'll use the 2D array. That's like this.
Okay.
And you can also say, well, I don't know why that's red. It doesn't like that. I might have a syntax error somewhere. Anyway, you could go as well, 2D equals a list, and then you could go 2D dot append an empty list, and this would result in the same thing.
For a one-dimensional array.
Well, this is a two-dimensional array. This is a one-dimensional array that has an array as its only container. And
Okay,
if I
so
want,
you don't have to let it know what type of array it is. It'll be able to tell from when it reads in the data set.
no, that's not true. It'll be, I mean, if I do this, I always have a one-dimensional array, and then I've essentially created a two-dimensional array by adding an array to my array.
I got it. Okay.
And Tyler, this goes to your this red is. Are there rules about variable names? Can they start with numbers in Python? In
Oh,
our
that's
dictionary?
exactly what's happening. No, they should not start with a number.
Okay, thanks.
D2, yeah, okay, nice. Okay, let's look at the next complex data type. It's called a dictionary, okay? Lists are ordered sets of data. We care about what order they're in. We, think of them as like things in a line. Lots of the time that doesn't make sense, but we still want data that's, in a collection together, but it doesn't matter what its order is, and we don't think about it in terms of its order. So, a good example is like your user data. Your user has a name, and your user has an email, and your user has an age, and your user has some preferences settings. But it doesn't make sense to just think of those things in a row. My name isn't user sub 0, and my age isn't user sub 1. So dictionaries give us the ability to map data to key values. So in the user example, I could go like user, and then I could say user's name is something. My user is named this, which is a horrible name, and their parents should feel bad, but whatever, we get over it. Their email address is something, tab@tabslab.com. This should be a string. So on and so forth. So we can use any type of data as a key, and we can use any type of data as a value. It's most common to use strings as the key. That's just the way it tends to work, because that's how humans tend to think. We give names to keys and then we get the values out, but it doesn't have to be. I can use one as a key. I can use none as a key. I can put numbers as a value, strings as a value, lists or other dictionaries even as values. I can nest these things as deep as I want. But basically, they're just an alternative collection where we don't have a mapping by 0, 1, 2, 3, 4. We have a mapping by explicitly set keys, and there's no order to those keys. We just have them. Okay.
So what is that syntax you're using there then?
This opening curly.
So you took a variable and applied it to the open close, but then you have Tyler 75, 1, and 24. I mean, how is that being stored? Do I care?
Great question. Oh yeah, you care. So this line, let's go through our debugger and watch this happening. So this one makes an empty dictionary, a dictionary with no keys and no values, and we can see it populated over here. It's also got a length that tells us how many keys have a value. None of them do. Then on this line of code, we're going to execute key examples is going to be set equal to a dictionary data type. That's what the opening curly brace means. We're going to make this a dictionary. And then each line in here, comma separated, is going to say, make a new key on that dictionary and give it the value that follows the colon. So make a key named Tyler in this dictionary and set it to 75. Make a key with the value 1 and set it equal to the text 24. And use none as a key and set that equal to this list 1, 2, 3. And I don't think we'll be able to see the key examples until all of these execute. So it executes those 3 lines of code, and then key examples appears. And I can even open up, I've got this list in here, right? And so this is key examples. And this is implemented under the hood. This is a hash map, if that's meaningful to you. Okay, we can get values out using this same bracket notation. So just like we had lists, I could go sub 0 and grab things by index. I can go sub and then use a key here and get the value associated with that key. So key examples sub Tyler grabs me 75. And key examples dot get Tyler does exactly the same thing. But there is a difference here. The difference is if I try to use the bracket notation, so let's stop this. If I try to do this, key examples sub, and then I type in a key that doesn't exist, this will throw an error. And I'll just try to execute this code real quick. And you see key error, ASJFKL, blah, 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 blah. The same thing I typed here. So that's telling me there is no key associated with that value. And in Python, it's illegal to ask for a key that doesn't exist. You get this error. But if I instead use .get, in fact, actually, I'll copy this line, comment it out. If I instead use .get, I'm allowed to ask for this key, but it will return the value none. So I could say, you know, print this. And then if I put a breakpoint here, run and debug, then you'll see I've, oops, continue on. I've got my key examples, you know, it's got these 3 values in it. And when I step over, none is printed to the screen instead of throwing me that key error. Okay, so these are 2 ways to get the same data, but this .get will allow you to find out if that key already exists, and it won't just throw an error if that key doesn't already exist. Okay.
So back to that, the print, key examples.get, it gave you a none because that didn't jive with what was in Tyler to begin with?
Yeah, that's right. There was no key.
So that's the key name right there, right?
Correct. Exactly.
Okay.
Yep. And whereas if I had done .get Tyler instead of all this garbage without these little quotes, oh my gosh. Some days. This would have printed 75.
5, gotcha.
Okay. We can also use this bracket notation to assign values on our dictionary. So we're saying key examples sub new key, create a key, new key, and assign the value new value. So if I step over here, you can see this new key just appeared with the new value, new value. Okay. And this is showing you what I already showed you. There is no 7, so that also printed none. There is no key of 7. And then this last thing is just showing that we can also loop over dictionaries. This is common to do. We don't get a guarantee on what order we get the items out. I think you frequently get them out in the order you put them in, but you can't rely on that behavior. You just have to assume you get them in a random order. But if I loop over this, in order to loop over dictionaries, the best way to do it is with this .items function. We say loop over the dictionary itself dot items, and then you'll get a key and a value for each one, and we can print them one by one. First it was Tyler, 75. Now key is 1 and the value is 24, which is, again, what we expected. If I can pull this down, I guess I can't. If I scroll down, 1 and 24 are matched. Now we'll get a new key, none, and that list. And then we'll get the last key that I added, new key, and new value.
So key is a defined word for an article in the dictionary then. Or whatever it is. What are we looking at here?
These are two variables that I made. So I could have called these like K and
I'm
V.
talking about here. So key is a variable,
Yes,
even in the print down here.
that's right. So if I run it this way, now it will break and it will tell me there is no variable named key. So I would have to, if I change it to K and V, I have to change it to K and V here.
Okay. Okay. It's not a programming thing.
That's right. It's not a reserved keyword.
Yeah, exactly. Okay.
Okay. Questions about dictionaries and what they're used for? Last thing we're going to talk about is making a function. And then I've got some, little challenging exercise we can do a few of before I said this would end at 1. So we've got a good amount of time to kind of work and read code. Sweet. Okay, last thing then, functions. Functions are, I should kill that session. Functions are ways to group blocks of code that we want to execute repeatedly. We want to execute over and over again. And they can accept data coming in, and they can produce data coming out. When they accept data, we say a function takes parameters. And when it spits out data, we call that returning data. Okay, so this function, compute2, is a very boring function. It takes 0 parameters because there's nothing in between these two parentheses, and it returns 2 because we used the keyword. So the anatomy of this thing is we define a function using def, and that's Python jargon. So we always use this keyword def to say, I'm about to create a function. Then we give the function a name. So this function is named compute2. Then you have an opening parenthesis, which you always have, regardless of whether or not you need any parameters. And between the parentheses, you add the names of your parameters. So this one doesn't have any. Then you close the parenthesis, and then you do the colon, which should look familiar from for loops and if statements. And then you indent, which also is just like for loops and if statements. You indent, and 4 spaces is the standard conventional indentation amount. Okay, so this function returns 2 always, the result of 1 plus 1, and doesn't have any parameters. This function, the add function, accepts 2 parameters, one that I've named parameter 1 and parameter 2. And again, I could name this anything, B and A, but if I name them A and B, then I have to change this to A and B. So these are just variable names, and I've chosen to name them parameter 1 and parameter 2. And then a colon, and then it returns the result of adding these two. So these are kind of toy functions, but just to demonstrate the syntax of creating a function. The def keyword, the name of the function, an opening parenthesis, the names of any input data, which we call parameters, and then a colon to indicate the function has begun now. So what do you think about functions? This, just the idea of creating one at least.
So return is what it'll spit out then, and that's a Python word.
It is a Python word, it's a reserved keyword, and it's a word that's common to a lot of programming languages. Lots of people I've never met a programming language where you don't at least refer to the thing that's returned as the return value.
So what's the difference between return and print?
Oh, great question. Okay, so print that we've been using, print is mostly for debugging purposes, and it causes that information to be spit out down here in our terminal, right? All of these were the result of print functions.
Mm-hmm.
And when we return a variable from a function, let's scroll down here so that we can see where we're executing the function. So right here, this line of code on line 20 says, make a variable named 2 and execute the compute2 function that we defined just a little bit above. And whatever value is returned from that function compute2 will be stored into the variable 2.
Okay.
But it won't necessarily be printed to our screen unless we do something like print 2.
Okay.
Sweet. And which, by the way, means print is a function itself, right?
Right.
Mm-hmm.
And so it's a function that knows how to access this little text zone that we call the terminal and put values into that terminal. It's a very special function that way. Okay, yeah, so then the last thing is just for completion, completion's sake. That's really not what I want to say. For the sake of completeness, that's the phrase. I want to show you this keyword called pass. Pass is a strange Python line of code that says, do nothing. Execute this line of code and do nothing, which is different from none, right? Which is a type of data that means there is no data. This is a line of code that says, this line of code doesn't do anything. Just wait. So sometimes people will define functions that they mean to implement later, and they'll just have that function pass and do nothing. If there is not an explicit return statement in your function, that function returns the value none by default. And if you hit a return function or a return statement in any function, that return statement immediately ends the execution of that function. So if I add this here, for example, this line of code is impossible to reach because, and look, it'll even tell me that it's got unreachable code, yellow underlines it for me, because this return statement happens and return halts the function immediately and returns the data back to wherever you called it. So this line of code can never be executed. Okay, and then this just demonstrates the use of functions. So let's put a breakpoint here on this line. And if we jump into the debugger, run the code, blah, 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 we'll get to this line of code. And now we can actually use these other two buttons, okay? So step over, if I step over this line of code, it will just run the code in this function and immediately jump to the next line of code. But if I step into this function, you'll see it takes me up to the function where it will return 1 plus 1, and then I can step over and it'll return me back here because that was the only line of code in that function, and it returned 2, and now 2 is 2. Okay. If I step into this add function, now parameter 1 and parameter 2 have been given values, the values 2 and 3. And this is just by position. 2 comes first, so the first parameter gets the value 2. 3 comes second, so parameter 2 gets the second value, the 3 here. And then these two things will be added together and returned. And I can always, if I'm in a function, I can step out of that function, and that function will run to completion, and then it will return me to the line where that function was called. And now 5 is about to be returned. We can see up here, I'm about to return 5 from this function add. And if I step over again, 5 will now have been assigned that value. So step out said, get to the point where this function is done, determine its return value, and then hold there for a second. Okay. And then similarly, I can step into this function that does nothing. It'll tell me, hey, I'm about to pass. I can step over that, and then nothing has gotten the value none. And if I print those things to the screen, I got 2, 5, and none. Okay. Of course, we can also send variables to functions. So now we've got the number 2 in the variable called 2. We've got the number 5 in the variable called 5. And if I step into the add function, now, this time, parameter 1 are 2 and 5. Again, because of the position of 2 and 5. And again, these variables, I just chose them to be 2 or 5. They could have been T and F, or your mom and your dad, and your mom and your dad plus each other happen to equal 7. That's a little strange, but who knows? Okay, so just coincidental that they're named 2 and 5, and that their values are 2 and 5. And then, I step over, boom, I get the value 7 in the variable 7, and I can print it to the screen. So that's the basic use of functions. What I'm going to have you do next is work together. And I'm going to make there's 2, 4, 6 of us. So I'm going to make breakout rooms of 2 each. And I'm going to ask you to try and determine what this code does. Try and describe in plain English what this first reading exercise number 1 code does. Does everyone have this on their screen? Because I can't send you to breakout rooms if you don't have it on your screen. Then you won't be able to see the code, right?
I have it.
I have it.
Oh, and there's not actually 6 of us. There's 5 of us because Nick and Jim, you're the same person.
Correct.
Let's just stick in one then. That'd only be 2 groups, and one of them would be in a group with me, and that's not very fun. So we'll do this all together, but communicate, collaborate. Stop, look, listen. Here's what I want you to do. Look at this code for about a minute. Then put a breakpoint on this line of code and execute the code and step through it. Practice using this debugger. Remember, on this first line of code, you're going to want to step into so that you can go into this function. And then try to reason about what's happening. I'm going to step through it really fast so that you have to do it on your own. But try and reason about what the meaning of this code is. So spend 1 minute before you jump in, and then start debugging. And I want you to look at this code kind of quietly on your own, debugging it, trying to figure out what it does for, let's say, 4 minutes. Well, let's say 5 minutes. That's a good round number. I'll start a timer for 5 minutes, and then I'm going to ask us all to kind of talk with the group. What does this code do? How'd you figure it out? Sound good?
Yes.
Yeah.
Okay. 5 minutes on the clock has started. And I'm going to freshen up my coffee. Don't worry, I'll be right back. What happened here? Okay. It has been 5 minutes. Who wants to, share? What is this code? Where are you at? What have you figured out? What's still confusing?
Personally, I still have problems running the debugger and running it through the line by line. I've been mashing it the whole time we've been talking, and sometimes I can't replicate what you've done.
That's pretty annoying.
Yes.
Can you run the code, to completion and see these values here?
Yes.
Okay, but the debug, run and debug doesn't quite work. What about Samantha and Hario? Were you able to use the debugger?
Yes.
Yes.
Oh, okay.
So it runs through, and I run through the code and see what you've done with true and false. But as a step through on the little sidebar on the left, I have trouble with. So I hit run and debug. It says Python file on the right there. Debug currently active Python file.
Yeah.
And I see the mystery function, built-ins, doc file loader name. It stopped at the breakpoint that I put on line 10.
Okay, nice.
So that's all working for me.
And then if you click step in,
Step in is the down arrow.
yeah, the down arrow.
It goes to the top. There we
Yeah,
go.
into the function.
Yes.
Was that what you were missing?
Yes.
Yeah. Okay. Hario, what do you think this function does in your, execution of the code so far?
So, excuse me, one more time. What's the question?
What does this function do? Or at least what do you think it does?
So how to say? So look for the thing in the things library, and if there is thing, return true. But if we cannot find thing, return false, like that.
Okay, yeah, I think that what you're saying is exactly right. So when we call this mystery function, right,
Mm-hmm.
it takes two parameters, things and specific thing.
Mm-hmm.
And when we pass it this list, 1, 2, 3, 4, 5, and this number, 4, it returns true because the number 4 is in this list,
Yep.
right? So when we're looping over for thing in things, if we step over this, then things is still just our 1, 2, 3, 4, 5 that we passed in.
Mm.
Specific thing is still 4 and will always be 4 because we never change the value.
Yep.
And this first time, 4 is not equal to 1, so we can step over it and it won't happen. So it advances thing to 2, and then it's 2's not 4, and 3's not 4. But 4 is 4.
Mm.
So when we step here, now it'll return true. When it returns true, it ends, so it'll never get to this line return false. We check back out, return value is true, and we print true. Boom. Okay, now this one prints false. Samantha, why?
Because in that one, the 4 with the quotation marks is a string, not an integer. So it's not part of the list.
Bingo, exactly. So we can step in here, and even when thing is 4, like it is now, 4 is not for the number. So the string 4 is not the number 4, so we didn't return true. We look at the last thing, 5, it's still not true, so we drop out of the for loop. We've looped over all of the things in the list. We didn't find it, and now we're going to return false. And then we print false. Jim, you feel good about reading this code? You understand what it does and why?
Yes, I can read the code, but trying to
Get it to execute was the problem.
yeah, I'm a little overwhelmed by the
New
compile.
tools.
Yeah, I mean not overwhelmed. I mean just I get a little frustrated when it doesn't. I mean it should be an easy thing to do, and I'm sitting there mashing things and nothing's working for me.
Yeah, no, I can understand why that's frustrating. Okay, so we got 45 minutes left on the plan. I don't know if everyone was planning on being here until 1. We've got 4 more exercises, but you've been in your chair for another hour. Do you folks want to take a short break right now, or do you want to keep going?
It doesn't matter.
No opinions.
I'm good.
Jim's good.
Sure, let's just mash it out.
Great, let's do the next one. Okay, let's do the next one. Boom, here's the next one, number 2. The question this time is both, what do these two functions do? And also, critically, how are these two functions different? So, we're trying to, again, define these functions in plain English and be able to predict what will they print. But of course, you can run the code and step through the code in trying to figure it out. Jim, do you want to share your screen as you work through this and see if I can make sure you're getting it right?
Yeah. Are you still there? Oh, I still okay. I guess screen 2 is where we were. No, screen 1 is it? There we go. I see what it does now. It highlights the screen. So you should see my
Yep.
compiler, correct?
Yeah, I do.
Yeah. So to start it on line 1, do I need to put the red dot on it to get it going?
You should put the red dot probably down on line 29 or 39. If you put the red dot on that comment, it might not ever execute because that line of code isn't executable.
Okay, so take that off. And
you
then, go ahead.
You could put it on line 2, which would stop it when it's creating the function, and you could step through the creation of the function. It wouldn't be terribly interesting to see in terms of figuring out what the function does, but it should still trigger the breakpoint.
So is that a step over or is that a step into?
Okay, so right now, what line of code are you frozen on? Do you know? Will you click on the little bug play window where you see the little blue 1 on the left of your screen?
1 over here. Okay.
Yep.
So hit run. Okay.
Oh, so you're still frozen on the last document. You can see specific thing and thing.
Yes, yes, yes.
So click the stop button here.
Which is the stop button?
Up on the right. Yep, exactly.
Okay.
And
So
now, exactly.
And I pick the Python file, correct?
Absolutely.
All right. So it's doing its thing. All
Boom.
right. Came through.
Okay, so now you're frozen on line 2. It's saying I'm about to define a function called mystery function. I'd step over this.
It still has the arithmetic function from the one before, though.
That's just telling you that there's a list of all built-in functions, and arithmetic error is one of the built-in functions.
Oh, okay. So I'm not stuck on the one before.
Exactly. Yeah, you're on
Right.
line 2, so you
Well, I
can
don't
step
think
over
I'm-
line 2. And now it's telling you, okay, you're going to create mystery function 2, so you can step over that as well. Now you're going to create this list of students.
Yeah.
And you can see in your locals, right, mystery function and mystery function 2 are now both defined over on the left under locals.
Yeah. How do I open that up to see the more of this piece right here?
Click the little down arrow next to mystery function, and or the caret, and it'll show you what's in mystery function, all the under
Got
the
it.
hood. So this is a lot of under the hood implementation details of how functions work.
Can I make that panel on the left wider?
Yeah, I think you can. You got to kind of get it at exactly the right spot, though. It's just irritating. Yeah.
There we go. Okay. All right, I'm good. All right. I'm with you. All right. So it's stepping through here down here with
Yep, and it's just creating each of those.
right. So if I step into, it'll do line by line rather than blowing through everything as with the step over. The step into is a line by line, and the
Yeah.
step over is through each one of the functions
Well,
or each segment of the.
they're
of
both
the-
they're both line by line, but step into will activate the function. So if you're like if you step down to line 39,
39, yeah. Oh,
yeah, so step over until you're on line 39.
okay. I am there.
Okay, so now the difference between step over and step into here is if you do step over, it'll execute mystery function with student names, and it won't show you the execution of that function at all. But if you step into, it will take you up to mystery function, and you'll be able to step through it.
Oh, okay. I get it. All right, I see it. I understand. I was just wondering, this little tipped over house, the yellow house. I wasn't getting that to come up.
Yeah.
It came up automatically somehow, or I had to purposely do that. So,
No, that's just that's the line you're currently executing.
gotcha. Alrighty.
Okay. I'm going to take back over as you read that code. Let's give everyone another 2 minutes, and then let's ask what this code does.
Hmm. Oh, yeah. I personally don't see the difference between the two.
Mm. Okay, well, time's up, so we're going to talk about it. Samantha, did you see the difference between these two?
No, I'm a little confused by this one.
Okay. The
I mean, the
difference,
coding looked almost identical.
they are almost identical. The difference here, look on line 8, is an elif versus a
Oh,
regular
okay.
if.
Okay.
Okay, was anyone able to, what does this function do? How does it process the list of names that it's given?
So is that one saying that if at position 0, the name does not start with A, then at position -1, you're looking for a name starting with C?
Not starting with, okay, so you got this. If the name starts with capital A,
You
we
count
bump up
it.
the counter.
Yep.
If it doesn't start with capital A, but it ends in lowercase z, also count it.
Yeah.
Okay, that's what, remember, -1 goes backwards around the horn in Python.
Yeah.
Yeah, okay.
So this function then, the value of counter by the time we've looped through is what? How could we say that in plain English?
What was that question again? What are you asking us?
What is the meaning of this value counter? Can we define what it means by the time it's returned to us, what it will tell us?
Well, it's just taking the summation
Yeah, of what?
of, it has to meet, well, this one here can meet either the A starting or the Z ending.
Okay, right, so it's gonna tell us how many students have a name that either starts with A or ends with Z.
Yeah.
So in our case, Amanda meets that criteria, 1, Adnan meets that criteria, 2, and Amos meets that criteria, 3, right?
And
So if I run the code up until here, I will have printed out, oh, I haven't printed it out yet, but missed return 1 is the number 4. Oh, sorry, because Taz met the criteria as 1, right? Taz has a lowercase z, meets the criteria, meets the criteria, meets the criteria, meets the criteria. But the output for this second one is going to be different. It's not going to be 4 because this is not an elif, it's an if, which means which student gets processed differently because of this new rule. And we can show you the rules right here.
Frank.
Okay, how's it change for Frank?
Or Tyler, because it doesn't have either or.
But Tyler wasn't counted under these rules. Tyler doesn't start with an A, and it also doesn't end with a Z. So that adds 0 to the counter. And down here, I still don't start with an A, Tyler doesn't start with an A, and Tyler still doesn't end with a Z, so I add 0 to the counter. Taz now comes in.
Oh, sure.
And this won't happen, but this will happen. So Taz adds 1 to the counter.
And Amos,
Yeah, what happens with Amos?
it adds 2. No, it's because it has an A in the beginning.
Oh, you were
with,
right, and then you doubted yourself.
oh, okay.
Amos does add 2 this time around, right? Because in this top version of the code, it says elif. And Amos says, well, Amos starts with capital A, and since it's elif, only one of these 2 blocks can happen. So this second one doesn't happen, because the first one did happen. But here, we get to Amos. His name starts with capital A. We add 1 to the count. And then here, it's not elif, it's just a separate if. It's like a separate question entirely. So Amos also ends with lowercase z, So Amos is counted twice. And if we step over this function, return 2 will be 5 instead of 4 because Amanda counts once. Oh, sorry. Taz counts once for the Z at the end of his name. Amanda counts once for the A. Zeke counts for nothing. Adnan counts once for the A. And then Amos gets counted twice, once for the A and once for the Z. And then Frank doesn't get counted. And that's the difference between if and elif.
Okay, so with the elif functions, it's like an either or kind of deal, right? They can't both run.
That's exactly right. And with just 2 if statements next to each other, they're both perfectly welcome to run.
Okay.
This one was trickier, right?
Yes.
Yeah.
But it makes sense as soon as we discussed it.
Hey, that's life.
Yeah.
Okay, let's do the next one. Why not? Okay. This next one I also think is tricky, but run the code, look at the output. Wow, geez, that's really interesting. Pause the code, step through, and try and think about it. And feel free to ask questions if you're confused about, you don't remember what something means, or, what's this dot get, or blah, 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 blah. Feel free to say it in the chat, but let's give you 5 or so minutes to read the code and process it.
Okay, another operational thing here. So I turned it off, picked the file, went to run and debug. I did it again, and it does that little menu goes away after I've run it, even though I'm on 3.py Python.
This window here?
Yeah, this stuff up here on top.
If you click the little bug play, you should get this window back.
Yes, but I get run and debug back.
Show me what you're looking at.
Sorry for being a.
You're good.
Operator error.
Yeah. Oh, so have you put a breakpoint in that file yet?
Oh, you have to put the breakpoint in?
Otherwise, it won't pause. Yeah.
Okay. I understand now. All right. Got to put a breakpoint in there. There we go. Okay.
Boom.
Thank you.
You got it.
I understand.
Okay, I like that sound. Oh, what's that mean?
Well, I see what it's doing.
Good.
But I find it interesting that it comes down here and picks up some string and loads it up in there when it's down here in the bottom.
Talk about these. You're talking about these lines of code, Jim, 17 and 18.
Yeah.
So yeah, why does that happen?
Because, you know, from my experience, it's sequential, right? You got to load it up before it does anything. You have to load it at the top for it to be processed down below.
That's true. And what happens here on line 18? What does the second part of line 18 mean?
Well, that's a function, and it loads some string values into that mystery function. And
Exactly. So when we execute this function, mystery function, we take the value of some string, we store it into the name of the input parameter for mystery function, and then we execute the lines of code that belong to mystery function. So that's why it goes down and then appears to jump back up to the top, because we're invoking or executing that function.
does it matter where that goes? I mean, would it still have done the same thing if you put it on top?
No, if I do this,
Yes.
okay, this will break. Let's run it and see how it breaks. Error, mystery function is not defined, because we're trying to
Oh, I got it. Yep,
use this function before we created it.
got it.
So I Control Z all that. I can now anywhere after line 3 has been executed, I can invoke the function, but I have to have created the function before I can use the function.
Yeah. I'm trying to remember if that's the way it worked when I was doing like Fortran.
In Fortran, I think, well, I don't know, I can say about C. I don't think I've written any Fortran, but in C, you have to have like a headers file that declares
Yeah.
all your functions first,
Yes.
and then you can execute them later, and you have to include that header at the top.
Right. Well, this is certainly more flexible.
Oh yeah, Python is
More.
way more flexible.
Yeah.
Okay, I had Samantha start last time. I had Hario start on the first one. So Jim, what do you think this function does?
Well, you define the function, and then you load it up with the data down below, and it's giving values. It's reading each character in some string, and I'm seeing, I didn't run it all the way through because we started talking about that, and it starts giving a value of 1 to T, 1 to H, 1 to I, and then it stopped.
Okay, so
But then I saw C up there, and it's giving an S. So I'm not sure.
okay, so you're absolutely right about this for loop. It loops over one time per character everything in input string, which is this string we defined down here. This is a boring sentence.
Right.
Okay, so if I step over right now, C is going to be T, capital T, and it'll do this for every letter. Okay, what about this thing? What is this doing? What is the return value doing?
Yeah. What is that combination there equals the brackets? What was that again?
Oh yeah, good question. Anyone else remember? What does this do?
Was that creating like a dictionary?
Okay, yes, this is creating a dictionary. So return values data type is a dictionary. And we're using that dictionary.get C, which again, remember C is the single character we're looping through the string. So right now it's capital T. So we're asking return value.get capital T. And we're asking, does that equal none? That is to say, does the key capital T exist in the dictionary return value? And if it does not exist, then this whole function call here, return value dot get C, will return none. Okay, so we could read this entire line of code as saying, if return value does not have a key associated with capital T, do what's in the if statement. Otherwise, don't do it, because if it already does have a key associated with capital T, then this won't be none. It'll be the value that's associated with that key. Does that make sense?
Yes.
Yes.
Okay. Then, with that in mind, can we describe what this whole for loop is doing?
Well, it's taking each of the characters and looking at it, and none means there's no value associated with it.
Right.
But each of those characters has a value associated with it, I presume. So
Well, not yet. In fact, let's step. Okay. We know that return value didn't have a key associated with T. So now on this line of code, what are we about to do? Return value sub C equals 0.
it's going to assign a 0 to it.
Right. Okay, so if I step over, now suddenly return value does have the value T, and it's assigned to 0. What about this line of code? It's going to do something slightly different but similar.
It's going to add 1 to it.
Right. So if I step, now I get T with a 1.
Okay. Yeah.
Okay. Now we're going to do this again for H, T, H. So now H gets a 1. Now I, because we're here, this, okay, I.
So is it assigning it a 0 to start with and come back and around and assigning a 1 to it?
It's assigning it a 0 if it doesn't exist, and then it's immediately incrementing that to a 1. Now, the real magic happens here when we encounter a value that we have seen before. Okay, so we're on S,
Yes, would be that.
so it's going to be the same. It's still not in there. Then when we get to this I, I'm going to skip ahead until we're at that I. I wish I could close. I don't want the watch. I want more space here. Yes. Okay, there we go. Okay. THIS and then space. Now we're doing space right here.
Oh, space 2, yeah.
Okay. And space gets a 0 and then gets incremented to 1. Now, C is I. And what's this going to return? Return value dot get C is going to be what? Is it going to be none?
No, because it has it in there. From
Bingo.
this. Yeah.
So it's not none anymore because there is a key associated with I. It's this value 1 here. So when we step over, we're not going to do the if statement, but we're still going to bump up this I to a 2. Okay, can we define this in plain English now yet? Are we close enough?
Anybody? I'll do it. So as you come into it, the return value is empty, so there's no value associated with it. It reads the first, it reads that this is a boring sentence statement and loads it up, and then it starts comparing itself back. And if it's seen it once, or more than once, it starts adding that it's seen it more than once.
That's right, so I'm going to put a, go ahead.
So we're basically just counting the letters in the sentence with this code.
Yes, we're counting how many times each character appears in the input text. And so if this little button, by the way, means play until you reach another breakpoint. So I put a breakpoint on line 12. We've now gone through the entire for loop. And this is telling us there are 4 spaces in this is a boring sentence. 4 spaces, 1 period, 1 capital T, 3 lowercase e's, 3 lowercase i's, 3 lowercase n's, 3 lowercase s's. So this code counts the occurrences of each individual character within a string. Groovy? Less groovy? Unradical?
No, that's
Oh,
cool.
that makes sense.
Sweet. Okay. This is a super common thing to do. Actually, I have been asked this question more or less in like 3 or 4 different programming interviews. This is the type of thing, it's popular in programming interviews to ask because it's the type of thing, if you've been programming for a while in a particular language, you can do it, and you can disguise this in a number of different ways. Count the number of occurrences in a string. You have a list of votes. Figure out who's the winner, who has the most votes. That's the same thing. You have to count it, and then you search through the counts and find the max. Stuff like that. So this is a common kind of thing to want to do. Count the occurrences of some, you've got a huge string of DNA. Count the occurrences of this particular sequence, or find the number of times this protein will be produced, or could possibly be produced, given an amino acid sequence, or yeah, given an amino acid, figure out how many times it occurs in that RNA strand, something like that. Is it cute when I'm trying to do work in biology to this thing? I'm doing my best.
You're doing well.
Okay, we've got 2 more of these, and I think we've got just about enough time. And then once we've done the other reading exercises, I'll show you these writing exercises. These are good challenges for you to try, and they come with solutions, so you can check and see if you're right. But so let's do number 4. This is fun. Not too bad. 5 minutes on the clock. What does this code do? And I'll be right back. 1 sec. Okay. Hario, I think we're back to you. What do you think this code does? He's gone.
Well, it's counting position. It's counting up the times it interacts with C, I, and J. So C is incrementally counted for the number of times it goes through.
Right, which is how many times?
I get 99.
Okay, well, the last thing it prints is 99,
Oh, maybe it goes on forever.
but it doesn't go on forever, but it gets incremented one time after it prints 99. See, this prints 99, then the final one of these happens, and you'll be bumped up to 100. That is to say, if I put this here, now if I run the code, it prints 100, right?
Okay.
So the position of the print statement doesn't change the number of times this runs. What does this thing do? This is a new function that I didn't tell you about. Range.
So that's just limiting the numbers to 1 through 10, right?
Exactly right. This is essentially range 10 is more or less this array, right? 0 through 9.
So range is a key Python word?
Yes, well, it's a built-in function.
Yeah, okay.
Yep, and it creates a list with 10 things in it starting at 0 by default. And you can look this up in the docs. There's other ways to call the range function, but when you do it like this, it basically says, run this loop 10 times, and I will get 0 through 9. And we can see that happens, right? We can see
Yes.
0 all the way through 9. This pattern here, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What does that tell us about how this is executing?
So it's doing the inner loop first, steps out, does the outer loop once, does the inner loop 10 times, comes out, does the outer loop, etc.
That's right, exactly. Okay, so we get here, and I gets the value, and we can even, this is a good one to just debug through. We get here, boom. When we step in, now it's going to do, I is going to stay 0, J is going to get a 0, and now we're going to print an increment C and do the J loop until we're out of J loop options, until we've gone all the way through.
Yes.
5, 6, 7, 8, 9. And then finally, when J is done, J is 9 now, we can't increment any further. We go back up to the outer loop. And then we do the inner loop 10 more times. Okay. And mostly this exercise is just to get you comfortable with how for loops work in for loops. Doing this kind of thing is actually pretty common. You don't always want to do it. It's pretty, computationally expensive. This is multiplication, right? This is 10 times 10. That's why we got to 100. So multiplicatively more data processing to do. But as we do it, we often have like for a list of objects or a list of dictionaries. For each key in that dictionary, do stuff. So this kind of for loop in for loop action is pretty common. But it makes mostly sense what's happening here.
Yeah.
Yeah.
Cool. Okay, great. Let's look at the very last one. We're on like a slight time crunch, but but this is tricky. Okay, this we've already seen before. This is the first function that we looked at just with different words. Okay, so this says give you an item, a list of items, and return true if a particular item is in that list. Okay, so that's what contains is doing. Now we use contains twice in this new function called intersection. Okay, and 3 minutes on the clock, your goal now is to figure out what this function intersection does. And the name is not a red herring, it's a hint.
You're probably comparing the intersections. What numbers in A and what numbers in B are similar?
Not just similar,
The
As a
same.
thing.
are the same. Exactly. Okay, so the intersection of A and B, what ought it to be?
3, 5,
Okay, yeah, 3,
5,
5,
1.
and 1, right. Okay, if we run this code, we can see that it does in fact do that. If I can click out of annotate, boom, boom, boom. Run it, scroll down, intersection prints 1, 3, and 5. So this code here, walk me through what it's doing, okay? Where outer item, this is maybe not the best variable name, but it's a thing from list A, and we're looping over 1, 1, 1, 1, 1, 1, 1. So how does this code kind of behave? What are we asking?
So I think it's saying if it's found in list B, as well as being in list A, then add it to the new list.
Okay, this first call to contains does what you just described. If the particular item we're looking at in list A is in list B, then this half of it is true. Then this half of the if statement is true. What's this half of the if statement asking? And actually, outer item is not a good name for this. I'm going to change this, whoops, to be item A, because it's an item from list A. I just think that's more clear. Okay, but this second half,
So you need to count that there's an object in one of those two that are the same. You're returning some kind of a value to say that that is true.
well, and the value I'm returning is this list that has copies of each item that exists in both. But this second half is actually doing something that's not related to list B at all. It's related to this return value. We're asking, oops, that's a loud noise. Here we're asking, is this particular item, item A, already in this list return value so that we don't double count items?
The return value is the new list that's being created for the intersection between A and B, right?
That's exactly correct. Yep, and so if, let's say I deleted this line of code and I added an additional 1 here to A, now if I run this code, I get 1351 because this number also occurs in list B, but we don't really want to count it, right? We'd rather have this line of code back in and I put the 1 back in here, save that, run it. Would rather just know each one that exists once, or at least I would rather know just each one that exists once. That's kind of what the intersection means. It should be a set, not a count of how many times it's duplicated.
So my question is that you have these variable names, list A, list B,
Uh-huh.
and item A as well. How do those variables see something that's just called A or B?
They don't. This A is and this A are only related because I chose. Okay, so this code will run exactly the same. It'll produce the same result if I replace A and B with X and Y. And now A is obviously not associated with this
Right.
value X, but
Oh,
this will do the same thing.
so the keyword intersection knows that list X or A or list Y or B are the first one's associated with the first variable in intersection, and the second one's associated with the second variable
Yes.
in.
Yes, that's exactly right. These are positional. So X was in the first position, which means it becomes list A, and Y was in the second position, which means it becomes list B.
That's pretty amazing that so free form. It's just,
Yeah, loosey-goosey.
yeah.
Yeah, for the two of you who this is your first programming language, you don't understand how freeing this really is, but I mean, it's quite amazing. Go back in time and learn to program in the 60s, and then you'd feel the pain. Okay.
Well, I don't think it was much different in the 70s. I did my first Fortran code in 1978.
Yeah, and it was still all statically typed. Yeah.
It was on a card. It was on cards.
Punch cards. Oh my God, that's a little piece of history. You had to write the binary code on a punch it out holes representing the binary.
Yep. Yep.
Good God. Anyway, okay, it's 101. I told you I'd let you go at 1. So what I want to say is these writing exercises are good challenges that I think are appropriate for a beginner level, but I want to show you how they work. So I've written a few very simple test cases for each one of the functions. This thing, assert, says if the thing following this evaluates to anything other than true, throw an error. So if I run this code at first, I get an assertion error on this line of code. Assert is palindrome race car equals true. That's saying my function is palindrome, didn't return the value true. The return wasn't equal to true. Therefore, I've failed this test. Okay. So my challenge for you maybe this weekend or maybe a little bit later today, if you're feeling really, like you've got the gusto and you want to keep programming, is think of a few more test cases, and you can add one like assert is palindrome AAA, and AAA is a palindrome, so you'd want to say true. Palindromes are things that are the same backwards and forwards.
Hmm.
And then fill out the code in here that would return true if the input string is a palindrome, and would return false if the input string's not a palindrome. And there's solutions to these all online as well. Lots of other ways to find out more information about this. But these are all relatively, I mean, not crazy easy. They're a good challenge, but these are all, I think, accessible based on what we learned about Python today. So do you have any questions for me before you take off?
Not at this time for me.
No, I don't have any. Thank you. This is great.
Yes,
Yeah,
thank
you're
you.
welcome.
Thanks, Tyler.
My pleasure.
So what is our access to you?
You can send me an email. I'll send my email in chat, tab@tabslab.com. I'd happily, whoops, I was sending that not to the whole group. Here's to everyone. I'll happily answer your emails. You can also connect with me on LinkedIn. My name's Tyler Batillion. I think I'm the only such. Actually, I do know of another Tyler Batillion who lives in Texas. That guy's a loser. Just kidding. I don't think he's a loser. But one time his mom sent me pictures of his wedding because we have really similar email addresses. And I was like, hey. Yeah, so
Okay.
feel free to connect with me on LinkedIn or send me an email. I'll happily chat with you in either of those places.
Okay, your email disappeared in the time I could write it down.
Oh, it's not still in chat. It's TEB
Oh.
at tebslab.com. And you can also go to my website. So someone probably shared with you this. This is how you found even the link to get to me.
Oh,
If you
yeah.
go,
Yeah.
if you go here on the contracting page, my
Yes.
email is here, hidden on the contact page. So you can find it this way as well.
Okay. Thank you.
Yeah, and plug, sign up for my newsletter. It's not bad. Okay, awesome. Thank you all for coming, and I'll see you around, or maybe I won't, but either way, I hope you enjoyed this.
Thank you.
Thank
Good.
you.
Yep.